Right, so this is page 46. Now we're looking at finding a standard deviation. So once again we're back to distances jumped in a school long jump competition along the x-axis. So x equals the distances jumped, and that's in centimetres. This time we're told there's a mean of 170 centimetres. Now if the probability that a student jumps between 170 and 188 is 0.3849, we're asked to find sigma. So the probability a student jumps between 170 and 188, probability of jumping a distance between those is the same as the area under the curve between the two numbers, and we're told that that area there is 0.3849. Right, so because I'm given the answer, given the area, I understand that this problem is an inverse one requiring me to go backwards. So if we go and try and use our calculator, now there's an issue with this one as well, because when I'm asked for a right tail, a left tail or a centre, you'll notice that I haven't got either in this case. There are many ways we can do this one. We could choose to left tail it by going up to 188 and using a left tail of that whole area, which would be 0.5 to halfway plus the 0.3849, which would give us a left tail of 0.8849. So that is one way. We could also do a central area, which would be between 188, that's 18, you'd have to subtract 18, you'd have to double the 0.3849, and then you could have a central area. Or we could do a right tail, which is the one I usually see. Oops, I don't want a mean of 0. A right tail, and instead of using the 0.3849 area, we could use the area this side of it, which is the right tail. Now obviously this is halfway. The area above this is 0.5. So 0.5 minus the 0.3849 that we were given will give us this right tail area of 0.1151. Right, trying to use an inverse, of course, we have a right tail, the area is 0.1151, but as soon as I try to use a standard deviation, we don't know the standard deviation for the distances jumped. So we convert to a curve where we know the mean is 0, the standard deviation is 1, and that is the standard normal Z curve, which we discovered in the previous video where we were learning how to find the mean. And I understand that to change from any normal distribution curve to the standard normal one requires the use of the formula x minus mu over sigma equals z. Substituting into the formula, the value on the x curve here that I used was 188. I subtracted the mean of 170, dividing by the standard deviation, which we don't know. When I converted that, we need to find our value on the z curve first. So back over here, right tail, standard deviation of 1, mean of 0. This value down here is 1.2 on the z curve. So there's my formula. You can have a go at putting it into Solver if you like. We could work out the top line. 18 divided by sigma is 1.2. Once again, you can go into Solver. We could write 18 equals 1.2 times the standard deviation by multiplying by sigma to bring it up to the other side. And then we could also note that to find sigma we could divide by 1.2. 18 divided by 1.2 is going to give me sigma. But at any stage, if you want to solve that, you can use Solve it on your calculator and you should get a value of 15 centimetres. Right, we'll work through another one. So here's another one, species of moa with weights, and once again we've got a mean of 170. Here are the weights of the moas along the x-axis. So x equals moa weight, and that's in kilograms. A quarter of the individuals in this species weighed more than 185.5, so the probability a weight was greater than 185.5 was a quarter, or 0.25 as a decimal, that's a quarter. Right, so that tells me that 185.5 must be up here, so that the probability of a weight being more than that is the same as the area under the curve, and that's got an area of 0.25. I can see I've already got the answer. I'm looking for the standard deviation, so therefore this is an inverse problem. And I know if I'm looking for a mean or a standard deviation, I am going to have to use the standard normal distribution with a mean of 0 and a standard deviation of 1. Following down below, on this z-curve, we need to know what value on the z-curve gives me 0.25. .6745, we'll round to 4 decimal places. Right, so to transform from any normal distribution to the standard normal distribution, we need use of the formula, which is on your formula sheet. The value on the x-curve that I've used was 185.5. The mean was 170. Standard deviation we don't know, and when I did that conversion the value of 185.5 is 0.6745. Right, you can jump on and use Solver at any stage. We can do a little bit of algebra on that. We can multiply by sigma over on that side, and then we could divide 15.5 divided by to give a value of 23 kilograms, and that's rounded to 2 sig fig. Right, you need to try some more.